The Paleozoic and Mesozoic marine sediments.
Before we dive in, it's important to know where we are on the geologic timescale. The Paleozoic era, also known as the Age of Invertebrates, consists of 7 different periods ranging from 542 million years ago to 248 million years ago.
The Paleozoic era was a time of fluctuating sea levels. A shallow sea covered parts of Idaho during most of the early Paleozoic, and a diverse assemblage of invertebrate animals inhabited the marine environments. The oceans receded during the Silurian and most of the Devonian, but then returned, and most of the state remained underwater during the Carboniferous and Permian. Some poorly preserved plant fossils and a few thin coal layers indicate that marine deposition was interrupted by periods of uplift and erosion. However, few of these terrestrial deposits have been found.
Next, we move into the Mesozoic era, known also as the Age of Reptiles, consisting of 3 different periods ranging from 248 to 65 million years ago. Near the end of the Jurassic period, the sea retreated from Idaho for the last time. At this point, the already uplifted central Idaho continued at an alarmingly fast pace. During this time, there was a lot of folding and faulting of the sedimentary rocks that had been laid down in the Paleozoic era. Triassic and Jurassic outcrops consist of metamorphosed and sedimentary rocks. These deposits have yielded a variety of marine fossils including mollusks, echinoids, corals, bryozoans, brachiopods, and shark teeth. The presence of raindrop impressions in the Jurassic rocks in southeastern Idaho suggests that some of the sediments were terrestrial or at least exposed during low tides. Looking at this map of Idaho, we can see the Paleo and Mesozoic marine sediments are found in the south-central and southeastern parts of Idaho. The rocks involved here are thick packages of sedimentary strata that have been deposited along a passive margin. This cartoon shows the rocks deposited along the passive continental margin of western North America that started to form in the late Neo-Proterozoic time about 700 million years ago. The figure shows the geometry of these strata. This tectonic unit is also known as the Cordilleran Myogeocline. After rifting in the late Neo-Proterozoic and thermal substance in the early Paleozoic, the passive margin was compressed in the latest Devonian time by the antler orogeny and modified by areas of major subsidence. In Mesozoic time, the passive margin rocks were progressively compressed and thrusted eastward as part of the Corrodian orogeny, thus producing what we now know as the Paleozoic development of Idaho.
Obviously, we are going to find sediments in sedimentary rocks, but which ones are most prevalent and why are they important? Sedimentary rocks contain invertebrate fossils such as trilobites, mollusks, brachiopods, corals, and bryozoans. These are great because all of these sediments can be used to determine the age of the rock surrounding them. Now that we know what type of fossils we can find, we need to know what rock types occur. I will give you a hint. We are dealing with the Paleozoic and Mesozoic marine sediment geographical region.
Chert is a microcrystalline or cryptocrystalline sedimentary rock material composed of silicon dioxide. Chert breaks with a conchoidal fracture and can form when microcrystals of silicon dioxide grow within soft sediments that will become limestone or chalk. In these sediments, enormous numbers of silicon dioxide microcrystals grow as dissolved silica is transported to the formation site by the movement of groundwater. Chert formed in this manner is a chemical sedimentary rock. However, some of the silicon dioxide in chert is thought to have a biological origin. In some oceans and shallow seas, large numbers of diatoms and radiolarians live in the water. When these organisms die, their silica skeletons fall to the bottom, dissolve, recrystallize, and might become part of chert nodule or a chert layer. Chert formed in this way could be considered a biological sedimentary rock. Hey, what's a sedimentary environment without limestone? Most limestones form in shallow, calm, warm marine waters. That type of environment is where organisms capable of forming calcium carbonate shells and skeletons can easily extract the needed ingredients from ocean water. When these animals die, their shell and skeletal debris accumulate as a sediment that might be lithified into limestone. Some limestones can form by direct precipitation of calcium carbonate from marine or fresh water. 3 of the most common types of limestone formed in marine environments are chalk, coquina, and fossiliferous limestone. Dolomite originates in the same sedimentary environment as limestone, a warm, shallow marine environment where calcium carbonate mud accumulates in the form of shell debris, fecal material, coral fragments, and carbonate precipitates. Dolomite is thought to form when the calcite in carbonate mud or limestone is modified by magnesium-rich groundwater. Sandstone is one of the most common types of sedimentary rock and is found in sedimentary basins throughout the world. The grains of sand in a sandstone are usually particles of mineral, rock, or organic material that have been reduced to sand size by weathering and transported to their dispositional sites by the action of moving water, wind, or ice. Their time and distance of transport may be brief or significant, and during that journey the grains are acted upon by chemical and physical weathering. Siltstone is also a clastic sedimentary rock that forms from silt-sized weathering debris.
As a result of all the uplifting and erosion, we have been lucky enough to get beautiful features such as the Idaho-Wyoming thrust belt, the Phosphoria Formation extending from Idaho to both Wyoming and Montana, the gorgeous Bannock and Malad mountain ranges, and the Wood River Valley located in south-central Idaho. Tectonics.
Looking at this map, we can see the Paleozoic sedimentary rocks as blue ridges. They were formed through extension and when the Farallon Plate was being subducted under the North American Plate. Currently, it is theorized that a divergent boundary lies below. It is a part of the Basin Range which is predominantly located in Nevada. These are mostly mountain ranges, including, but not limited to, the Lemhi's, the Beaverhead Range, the Wood River Range, Pioneer Range, the Little Lost River, and, of course, the Malad and Bannock Ranges. Many of these faults formed during the Silurian orogeny, and in this region there are both thrust faults and normal faults.
This brings us to the current topography. As stated before, the Paleozoic and Mesozoic marine sediments are located in southeastern and south-central Idaho above the Brigham Group. They are mostly comprised of mountain ranges and limestone beds, and it extends out in arms.
What are the natural resources and hazards of this area, you may ask? This area is made up of extensive cavern systems. These systems are crucial because the springs supply important parts of the municipal water supplies, for example, Minnetonka. Another natural resource is the abundance of salt beds. In this region, mining is also a big commodity. Not only do they mine for ore and other precious metals, but they also use it as an opportunity to make fertilizer. Limestone, obviously, is a huge part in this region. It has many uses, but it is extremely useful in construction, as said before. It is used as a crushed stone for road base and railroad blast, and it is also used as a dimension stone, roofing granula, and smelting and other metal refinery processes.